Okay, number 2 tells us to evaluate the following expressions. So again, we have kind of like a part A and a part B, 2 little mini problems here. So let's work with part A. So we have sine inverse, or inverse sine, of cosine of 4 pi over 3. So the thing is, we're going to work from inside to outside. So the inside is actually something we know, right? Because we can figure this out by just looking at the unit circle. Alrighty, so if we look at the unit circle here, we have, okay, so this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3 is right there, and our cosine should be a negative 1/2, okay? So cosine is equal to negative 1/2, because that's like our x value of that point there. Alrighty, and then we can say, okay, so now we can replace this inside with a negative 1/2. So now our problem is sine inverse of negative 1/2, and we actually solved this on the previous slide. And by the same process, we could get that this is negative pi over 6. Okay? Or we could write this, hold on, maybe a little more formal, negative pi over 6. There we go. Okay? Now for part B, we have a inverse tangent of 4 inside of a cosine. Okay, so that's a little bit weird. So what is this? This, like I said, inverse tangent functions, inverse trig functions, including the inverse tangent, they always give you back an angle, right? So we're looking for some angle in here. Okay, so some tangent of some angle is equal to a 4. Okay, this is kind of like saying 4 over 1. So what we can do here is kind of just write a triangle, okay, or draw a triangle. We'll construct one here. Let's say this is our angle, and this is, tangent is opposite over adjacent, so that'd be 4 over 1. Okay, and we can figure out this other side here by just using Pythagorean theorem. So c squared is equal to 4 squared plus 1 squared, which is equal to 16 plus 1, which is 17. So c is equal to radical 17. Okay, so c is equal to radical 17 there. So what does that tell us? We're looking for this angle here. So if I rewrite tangent inverse of 4 is equal to some angle, we can just plug that in directly for this guy and we'll replace it with a tangent. So what we're looking for is really cosine of that angle, okay, of that angle theta, right? So if we look at our same triangle, because we're dealing with the same angle and everything, and to find cosine theta, we need to take adjacent side, the length of the adjacent side over hypotenuse, okay? And from our picture, our adjacent side is 1, and our hypotenuse is radical 17. Okay, so cosine theta is equal to 1 over radical 17, or we can rationalize this to make radical 17 over a 17. Okay? Okay, number 3 tells us to find a simplified expression for this expression down here. So this rather complicated expression. So the thing is, we're going to start with this guy. So cosine inverse of x over 5 is equal to some angle. Okay, this is the same as saying cosine of some angle is equal to this x over 5. Okay, so again, let's construct some kind of triangle. So let's say we have something like this. So we have theta there, and cosine is equal to adjacent side over the hypotenuse. Okay, so this is kind of like saying we can assign x down there to the adjacent side and 5 up here to the hypotenuse. So in order to figure out a, we can use Pythagorean theorem. So we can say 5 squared is equal to a squared plus x squared. So if we solve for a, we're just going to subtract the x squared over to the left side. So we get a squared is equal to 25 minus x squared. So a is equal to plus or minus square root of 25 minus this x squared thing. Okay, and we're going to pick the positive answer. Okay, so a is equal to positive 25, radical 25 minus x squared. So this is going to be radical 25 minus x squared. Okay, and what we're really looking for, so this cosine inverse of x over 5 is actually equal to theta. So we can rewrite this expression as sine of theta, right? And so if we're just looking at sine of theta, that would be opposite over hypotenuse. Okay, so opposite is going to be radical 25 minus x squared, and hypotenuse is going to be 5, and that's it. That's going to be our answer, or our simplified expression for what we were given in the beginning. Alright, so that concludes our practice problems video for this section on inverse trig functions. I hope that helps, and good luck on your homework.